Okay, this video is going to continue talking about how to graph linear equations, but we're going to focus on graphing in standard form. So let's review real quick just graphing in the forms that we've already learned before. And the first one is slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. And we did that should have been a review from the past. We also talked about graphing horizontal and vertical lines. And we remembered that horizontal lines, one of the tricks I showed you today is that horizontal lines are lazy. So if it's just a y equals line, that it's going to run this way, it's going to lay down. And one of the other tricks to that was to remember that the z tells you that you have a zero slope, or a horizontal line, however you want to think about that. And then x equals lines are going to run completely vertical, straight up and down, and going to have an undefined slope. So it's important for you to remember those things. All right, so today we're going to talk about standard form, and standard form is still linear, and we need to discuss the difference between linear and not here in a minute. But standard looks like ax plus by equals c. And sometimes it's going to be important for us to write equations like this, but you're going to see some that you have to graph this way also, especially when we get to some word problems here in the future. But a, b, and c in this are numbers, the same way that m and b are numbers in slope-intercept form. So the question is, how do we graph functions when they look like this and they're in standard form? So the first option, I think, is one that you've actually learned in 8th grade or pre-algebra, whatever course you've previously taken, and that is just to change this over to slope-intercept form. So we want to rearrange this equation so that y is by itself. So this -5 is attached to the y. It's going to be the last thing I can deal with. So instead of trying to separate those, I'm going to move this 2x, and I'm going to do that by subtracting 2x from both sides. Now, a few things. I want you to notice that right here where I'm writing this minus 2x, I offset it from the 20 because I can't do 20 minus 2x because one has an x and one doesn't. So I need to remember that those are going to end up just being separate pieces. So when I write what I have left, I currently have -5y equals -2x plus 20. Now, some people say, well, can't I write that as 20 minus 2x? And you certainly can, but since we're trying to change this to be mx plus b, I want the part that has the x with it to come first. So that's why I write mine -2x plus 20. And the plus 20 is because this is a positive 20. All right, so now we only have one step left to get y by itself, and that's to divide by -5. And you want to remember to divide every single piece. So you should probably put a star in your notes next to that step that reminds you to divide each piece of the equation. And when I do that, I'm going to get y equals. We want to simplify each part. So if you could divide this first fraction, this -2 over -5, you would. Neither of those simplify, but the negative of the negative does. So I can change this to positive 2 over 5x. And then the 20 over -5, that does divide. That becomes -4. And we don't want like plus negative. It's just positive 20 divided by 5 is -4. So that's where I'm going to leave my answer. Okay. Now that I've done that work, I'm ready to graph just like we did last week. So you may want to pause the video and graph real quick and see if you can make sure you get that right, and then we'll move on. So you should have this graph for yourself in your notes, but just to check, I started at -4 and then rise to run 5 to the right and down to the left 5 to continue my line. Now, I don't think this is the easiest way to actually graph this equation, and I want to show you why. And before I explain that, I need to tell you what intercepts are. So you already know y-intercept because of slope-intercept form. So intercepts are where lines cross or intersect an axis. And there are two different kinds of intercepts. There are x-intercepts and y-intercepts. So x-intercepts are obviously where the curve is going to be crossing the x-axis. And if we take a second to plot, I want you to pause the video and just plot 3 random points on the x-axis and name them as ordered pairs. All right, and you should probably have 3 different points than I do, but if you look here, I've noticed that all of my points have a number in the front spot where the x value goes and a 0 in the y spot. And that should make sense because y would indicate that I was trying to move up or down, and all of these points are just on the x-axis. They're not moving up or down. So x-intercepts are all written in the format x, comma 0. So it's important for you to know that. So pause now and do the same thing but with points on the y-axis and see if you can figure out the pattern there. So pause the video. Okay, so I noticed kind of a similar pattern here. In all the y-intercepts, there's a 0 in the x spot because I'm not moving left or right any, and there's a value in the y part of the coordinate. All right, so it's important for you to know that that's how x and y intercepts are written. So let's look at an example, like I said, of how to graph that first problem a little bit quicker. Okay, so I think that this question is actually easier solved with intercepts. So I want to kind of give you some notes to take. Let's imagine that we're solving for the x-intercept, which we said was written in the format x, comma 0. Well, that 0 means that the y part of the equation should be 0. So I'm going to write it that way. 2x minus 5 times 0 equals 20. Now, this is going to look longer for a second, but I promise you I'm going to show you how we can solve these in our head. I just need you to see exactly what I'm doing mathematically. All right, so I plugged in 0 for y because I know that's how all x-intercepts are written. And I'm going to work that out. I know that that's just 2x. This 5 times 0 is just 0, so I'm not even going to write that down. 2x equals 20. All right, that's going to be x equals 10. So I know that the x-intercept is going to be the ordered pair 10, comma 0. All right, I'm going to do the y-intercept similarly. Y-intercept. And the y-intercept is written in the format 0, comma y, where that 0 is the 0 for the x value. So I'm going to take that original equation again. 2 times 0 minus 5y equals 20. Now I know 2 times 0 is 0, so 0 minus 5y is just negative 5y equals 20. So y will equal negative 4, which is going to give me a y-intercept of 0, negative 4. Now, a few things. It is important for you to actually write out how these x and y intercepts are written as ordered pairs, not just single values. And then we want to go ahead and plot them. So the nice thing about this is we don't even have to rearrange for slope. It just gives us 2 points and we can connect. So the x-intercept is 10, so I'm going to plot a point on the x-axis at 10. The y-intercept is negative 4, so I'm going to plot a point on the y-axis at negative 4. And then I can go ahead and connect those with a line. And that is my function. Now, again, you may not say that that's quicker, but let me show you why that is. Okay, so here's 2 quick examples of how this is actually quicker than having to solve for y. So this is called cover-up method, and the reason I call it that, I know that if I plug in 0 for y, that this whole piece is going to go away. So I'm going to cover it up for just a minute and go ahead and write down my equation, which is going to leave me with 3x equals negative 15. So I know my my x-intercept, because x is what I'm solving for, is going to be negative 5, 0, because if I divide that by 3, that's negative 5. All right, then if I do the same thing for the x, my equation is now going to read 5y equals negative 15, which gives me a y-intercept of negative 3, so that's 0, negative 3. And then I can just go ahead and plot those 2 points, negative 5 on the x-axis, negative 3 on the y-axis, and I have my graph. All right. You can also kind of do this in your head. At some point, you're going to get good enough that you don't even have to write the 2 equations down. So same thing. If I cover up the y, that's going to give me negative 6x equals negative 18, or x equals 3, which is the intercept 3, 0. If I cover up the x, that's going to give me 2y equals negative 18, which is y equals negative 9, or 0, negative 9. And again, I can just plot my 2 points. X is at 3, y is at negative 9, and connect my line. So I hope that you see this really is quicker as long as you can get the method down. Now there's one kind of exception for when this rule doesn't work. So I want you to think about these 2 examples. and the other examples that I've shown you, and think about when is it that you cannot use this intercepts method? When can you not use option 2? And that's going to be your warm-up question for tomorrow, or at least part of it.